Good afternoon, everyone. My name is Gr.12. I'm a physical science teacher, and today we'll be focusing on electric circuits. As Friday, this is one of the questions that is going to appear in your paper 1 physical science. So we've got a few days to go, and it's important that we really revise this. So just quickly, the overview of what you should remember from the exam guide. If you look on page number 5 of your exam guide, it explains clearly to you what is it that you must remember from your grade 11 work. Most of the time, this is a very problematic area because there's no time of going back in class to do revision from grade 11. But if you take your grade 11 exercises and you practice electric circuits, the questions are fairly easy, and it's quite easy to come up with most marks from these questions. So if you have a look at what is it that you must remember from grade 11, the relationship between current, voltage, and resistance, that is according to Ohm's law. We'll quickly have a look at what type of question that you can expect from Ohm's law. And then another thing is the definition definition of electric current, which is defined by this equation there. I is equals to Q over delta T. And this is a typical question that can appear from question 1 where you state one weight. And then stating the difference between ohmic and non-ohmic resistance. If you remember well, according to Ohm's law, we'll have a look at it later. According to Ohm's law, let me just show you quickly what I mean by the difference between ohmic and non-ohmic resistance. If you get the relationship, that will give you a straight line graph through the original. This graph indicates that the resistor that you are using is an ohmic resistor. So if you look at the graphs, these three graphs, this one gives you an ohmic the relationship between V and I, that is ohmic resistor. And then this one, it's not a straight line, though it's from origin, it's not a straight line, therefore this is a non-ohmic conductor. An example can be a light bulb. And then the other graph that represents the non-ohmic resistor is this one for the semiconductors or semiconductor devices. All right? So it's important to remember that if in a multiple choice you are given the graphs and they say from these four, which one is an ohmic resistor or an ohmic conductor, then you look at the one that has a straight line graph through the original versus I. So those three graphs, you will choose this one as the correct one for the ohmic resistor. Then another thing that they say you must remember here is solving problems. Solving problems using the equation R is equals to V over I. This is straight from the Ohm's law in ways, and this the definition also, remember, take it from this book that I'm using now. Because from the textbook, sometimes they state it differently, and in the examination, they want it from what they gave you. This is what they gave you as the guide towards the examination. So there is your definition of or stating of the Ohm's law. And then we'll also look at the calculations, that is work done or energy transfer, using those different equations there. And then also look at power, calculating power using those equations there. So another thing that you must remember from grade 11 is the resistance, the equivalent resistance, that is for parallel and series circuit, and the internal resistance. So they say here you must be able to calculate equivalent resistance. And what do we mean by equivalent resistance? We mean if I've got 3 resistors, 1, 2, 3. And these resistors are connected in parallel like that. And then let's call this R1, R2, and R3. So those three resistors that are in parallel, the equivalent resistance is if I take them all and remove them and put one resistor that has the same effect as those three resistors together. So this will be the equivalent resistance of those three. So you add all those three to make one resistor. So you will know how you add those three. We will have a look at it later. Okay, let's have a look at it now. Remember that if it is connected in parallel, you've got 1 over R parallel, which is equals to 1 over R1 plus 1 over R2 plus 1 over R3. So the total that you're going to get here at the end of the calculation, which is your R parallel, whatever amount of ohm, this will be the equivalent resistance of those three resistors. That is what we mean by equivalent resistance. All right? And then the other thing that they say you must remember here is solving problems using, involving current, voltage, and resistance. That is that equation there. And then from there, stating that the real battery has internal resistance. Of course, sometimes the question might say ignore internal resistance, but it doesn't mean that the battery doesn't have resistance. It does have. But for this particular question, they say you must ignore it. If they say you must ignore it, you must know that you don't take it into consideration. But in real life, the real battery has internal resistance. And then the other bullet says you must be able to explain why there is a difference between the EMF and terminal voltage of the battery if the external resistance of the circuit is comparable in size to the battery's internal resistance. So remember, when the switch is open, the reading that we get across the terminal of the battery is the EMF, but immediately when the circuit starts functioning, the current starts flowing, the charge starts flowing, then we have the potential difference. All right? And then the last bullet here says you must solve circuit problems in which internal resistance of the battery must be considered. So we are going to have a look at those as the questions and see how you are supposed to solve them. And then the last topic that we are going to look at is the series parallel resistors. So they say here you must be able to solve circuit problems involving resistors in series with the maximum of 3 resistors in parallel. All right? So you'll see that if you have a look at the past question papers, when they give you a circuit problem, that problem has the combination of the parallel and the series. So we are going to have a look at how you're supposed to target those type of questions and be able to solve them. All right. Remember, one of the things that we talked about here was Ohm's law. So I've got some few things here that I want you to have a look at how you solve the problems involving Ohm's law. Okay. So this is the investigation that is related to Ohm's law, and here we are going to have a look at the relationship between the potential difference and the current. So, okay, remember, one of the questions that they can ask is you must give the components of the circuit that you are going to use in this experiment. So those are the battery, the ammeter, the voltmeter, and the resistor. You also need a switch, and then you also need the conducting wires. All right? So the other thing that I want to highlight here is the variables in terms of the independent variable and the dependent variable. So the explanation that is given here is that if we are asked about the independent variable, especially for this experiment, so what you will consider there is what? You will consider the one that you are able to control yourself. That is, in this case, it will be the current. You can determine how much current you want by changing the number of cells or the number of batteries that you are using in the experiment. So when you increase the number of batteries, you know that you are increasing the strength of current. So this one, the current here will be referred to as the independent variable, the one that you can control. Then the dependent variable, before that, okay, this independent variable, remember we use the ammeter to measure the strength. We use the ammeter to measure the strength of the current in the circuit. So the independent variable, this one you cannot control, but you can measure using the instrument that is the voltmeter in this case. So if you cannot control it, then it is referred to as the dependent variable. Okay? So we use the voltmeter here to measure our variable, which is the potential difference. All right? And then if you have a look at your dependent and the independent variable and look at what you are investigating here, the relationship between potential difference and the strength of current. So from the investigative question or from the information, they will tell you that here we are going to investigate the relationship between this and that. You must know that whatever you are investigating, your variables, the dependent and the independent variable, they come from what you are investigating. Okay? So the other thing that you must remember is, or that can be asked, is the control variable. So this is the variable that you must control so that it doesn't affect the results. So we control it so that we make our outcome to be fair and reliable. Because if you don't keep that constant, then it's going to affect the readings. And then in this case, we keep the temperature constant so that it doesn't affect the reading that we are expecting from this experiment. Okay. And then the other question that can be asked here is for you to state your hypothesis. So you ask yourself what is hypothesis. You learn about this from lower grades. So this is the prediction of the results. And what you are supposed to write here is you predict the results. Okay, let's write it here. That's the prediction. You predict results where you are comparing the dependent and the independent variables. And because here we are predicting, our prediction might be correct or might not be correct. So what is important is that in your hypothesis, you must state that the relationship between dependent and independent variable is this. Like you will say, in this case, remember we are talking about current and potential difference. You will say when the current increases, the potential difference also increases. Or when the current decreases, the potential difference decreases. So that will be your hypothesis. You are predicting that when you add more batteries, the potential difference will increase, or when you decrease the number of batteries, the potential difference will increase. That is the prediction that you will be making from the experiment. All right. So the last one is the conclusion. The conclusion. So if you look at the hypothesis, which was our prediction, and the conclusion, both of them, they are the same thing. But the difference is the conclusion must be the correct statement. So the hypothesis, even though if it's not correct, we make it right as long as you've got your two variables that are compared. But then the conclusion must be the correct statement from the results. All right? So those are the things that you must remember in terms of the investigative question that you can come across when you deal with the Ohm's law in electric circuits. All right. So after here, let us quickly have a look at these notes. I believe you have them. These are revision notes that were supplied to your schools so that you can be able to focus your studies on what is it that you need for the exam. All right. So we are going to have a look at this, and then the activities that you are going to do is also coming from this handout that you are supposed to be having. All right. So if you look at the information here and what we discussed in the exam guide, these are two information that are similar. It's just emphasizing what is it that we need to know by Friday when you go into the exam room. So we talked about Ohm's law, and there is the definition of the law, and then this equation